Functions and graphs, intersecting functions. Find where the function fx equals x squared minus 2x minus 8 intersects the function gx, where gx is equal to minus x minus 2. So here we've got two functions and we're going to see where they cross each other. So finding where fx equals gx, we're going to make them equals with an equal sign. So f of x is x squared minus 2x minus 8, and g of x is minus x minus 2. So we're going to find out where are those two equations equal. So substituting in, we get x squared minus 2x, taking the x across, we get plus x, minus 8 and the plus 2. So we get x squared minus 2x plus x minus 8 plus 2 equals 0. Solving now, we get the x squared, the minus 2x and the x gives us a minus x, and minus 8 plus 2 gives us minus 6. So we now have a straightforward quadratic equation, x squared minus x minus 6 equal to 0, and something that we can factorize using factors in algebra. So looking at the factors, the x squared is going to be x by x. And the minus 6 could be a few things. It could be minus 6 and 1, but that wouldn't look promising there. But minus 3 and 2 does. So x minus 3 by x plus 2 seems to be right. The minus 3 by the 2 will give us minus 6. And the minus 3 by x and the 2 by x will give us an overall minus x. So if x minus 3 by x plus 2 is 0, either x minus 3 is 0 or x plus 2 is 0. If x minus 3 is 0, x is 3. If x plus 2 is 0, x must be minus 2. So if x minus 3 and x plus 2 are the factors, these are the roots. So what we're saying here is that when x is 3 or when x is minus 2, both of these two equations cross each other. Now, we may not have spotted that link in the factors with the x squared minus x minus 6. We may not have spotted the factors. So if not, we could have used the quadratic equation, ax squared plus bx plus c equals 0. So substituting now, the first coefficient, a, is ax squared, so it's 1x squared, so a is 1. Bx is minus x, so b is minus 1. And c is minus 6. So we just write the numbers there because we're going to use them now for substitution purposes. So x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. That's a standard formula for finding the roots of quadratic equations and given to us. So we now substitute the values. b is minus 1, so this becomes plus 1. Plus or minus b squared is minus 1 squared. Minus 4 times a is 1, and c is minus 6. All over 2a, or 2 times 1. So really, it's now a question of just the arithmetic. The plus 1 stays as plus 1. 4 by 6 is 24. Minus by minus is plus. Now that's 24 there. Minus 1 by minus 1 is 1. So 1 plus 24 is 25. So that's the square root of 25. And on the bottom, 2 times 1 is 2. So the square root of 25 is 5, so it's 1 plus or minus 5 over 2. Taking the first root, we get 1 plus 5 over 2, or 6 over 2, and then 1 minus 5, or minus 4 over 2. So 6 over 2 is 3, minus 4 over 2 is minus 2. Exactly what we got with the factors, but we've now definitively got it using the equation. So we have at x equals 3 or x equals minus 2, the x values where both of these functions cross over. So let's calculate the points on the function for those given x values. We know that gx is minus x minus 2. So if we put in the value of 3, which we got, g3 would be minus 3 minus 2 or minus 5. And g minus 2 would be minus 2 is equal to minus 2 or 0. So in effect, we've got the 2 points, 3 minus 5 for our xy value, and minus 2, 0 for our xy value. And both of these are points of intersection of gx and fx. We could check the process using the f function. F is given by x squared minus 2x minus 8, and plug in the same values again of 3 for one of the points, so it will become 3 squared minus 2 times 3 minus 8, or 9 minus 6 minus 8, which is minus 5. Or for the x equal minus 2 value, minus 2 would be minus 2 squared, minus 2 minus 2, minus 8, all of that would be 4, plus 4 minus 8 would be 0. Or again, the 2 points, 3 minus 5 and minus 2, 0. That's exactly the same intersection points we got for gx. And if we were drawing the function, this is what we would get. We would see that the fx, the blue graph, would be x squared minus 2x minus 8, and the gx would be the red graph. And we can see here that at minus 2, 0 and at 3 minus 5, both of those functions intersect. The question now is, where is fx and gx, where you've got those graphs, where is fx greater than gx? So let's look at this graph again. Sometimes here the blue is above the red, so at this point here minus 3, the blue would have a higher value than the red. And for example at point 5, when x is 5, the blue is much higher than the red. But somewhere here it seems to change. For example at point 0, the red is above the blue. So how do we find when the fx is greater than the gx? Well, from observation we can see that when x is greater than 3, at this point here, any point above 3, looks like the blue is now taken off, it's crossed the red line and it's getting bigger. And similarly, when x is less than minus 2, down here, it looks like the blue is again bigger. So we can mark those as shaded areas. So all of this shaded area here to the left and all of this to the right is when the fx is greater than gx. And in this space here, it's the opposite, when fx is less than. And at those 2 points, that's when they're both equal. So how do we do that? Well, fx is greater than gx when x is greater than 3 and when x is less than minus 2. So there are 2 equations there. If we wanted to put it in one equation, we could join both expressions. We could put the minus 2 here because it's lower and the 3 higher, with a lot of space in the middle. We then put in the x, and we say we want to link minus 2, 3 and x in one go. We look now and say, which one do we do? Well, the x was greater than 3, so that's part of it. X was greater than 3, so that's just taking that equation down there. Now in this situation we had x and minus 2. X was on the left and the minus 2 on the right. This is different here. But if we consider moving from x to minus 2, on our journey we hit the point first before it opened out. Whereas from x to 3 we had the open out before the point. So when x to 3 it opened out before the point, when x to minus 2 it hit the point first. So in this substitution, going back, we should, in moving from x to minus 2, we should hit the point first. So in effect, minus 2 is greater than x is greater than 3. And that's the way we would express that as a single expression.